In this chapter, we are going to see a new way to expose your C++ data to QML. And you are mostly going to use this way if you want your data to be instantiable in Qt-Quick. I want you to think of a way you define rectangles or images in Qt-Quick. You type a rectangle and then you put your curly braces and you put the data inside. We're going to see a way you can use your own data types like this in QML. We are going to start by defining our own custom type and use it to build the counter in Qt-Quick. We're going to see how you can expose C++ enums. We're going to build a new version of our counter using enums. We're going to show you how to work with objects and list properties in QML. Think of providing a list of your own types as a property to some other QML element. This is what we're going to do in Qt-Quick. I know this might not make sense yet. You're going to fully understand how this works as we go through the chapter. We're going to show you how to work with inherited types, default properties, grouped properties, attached properties. These are the concepts you might be familiar with from Qt-Quick, especially attached properties, grouped properties. We are going to show you how to build these features into your own types. We're going to see property value sources. Think of how you work with animations in Qt-Quick, for example, number animation on some property. We're going to show you how to do the same thing for your own properties. This is a very interesting chapter, and it's going to add a lot to what you saw in the first chapter of the course. In the next lecture, we're going to create our own C++ class and instantiate it in QML. I'll see you in the next lecture. In this lecture, we're going to see how to register your own types that you can instantiate on the QML side. The way you expose your data is really not that different from what we've been doing so far. You have to create a C++ class. The class has to inherit QObject. You have to have the QObject macro. You also have the option to expose your properties using the QProperty mechanism. The only thing that changes here is that you don't use setContextProperty or setContextObject like we have been doing so far, and you use another method that is called QML_register_type. This is one way to register your type. We're going to see many others, but in this case, you can expose the counter class. Counter is our own custom C++ class that we are exposing to QML. You have to pass in a few parameters. You have to pass in a string that identifies the library or the module that contains the class. You have to pass in a major version, a minor version, and you have to pass in the string that you are going to use to instantiate that object in QML. This is really all you have to do on the C++ side. You define your class and then you expose it like this. On the Qt-Quick side, you have to import your module. And you see the name we used here, comblyconcounter 1.0, is what we used to register the type, comblyconcounter. And 1 is the major version and 0 is the minor version. You have to import like this, and then you can instantiate your counter like this. I know this might not make sense yet. We're going to go to Qt Creator and show you how to use this exactly. Okay, here we are in Qt Creator. We are going to create our project. It's a Qt-Quick application as usual. We call it custom types counter demo. Store it in a location on our drive. We choose our Qt version. We choose our kit and finish. The first thing we want to do is to create our counter class. Let's do that. Counter. It's going to inherit QObject. And now that we have the class, we are going to create a bunch of properties. We're going to say QProperty here. It is going to be an integer, the first one, and it's going to say count. We're going to put in a second property. It's going to be a bool, and it's going to say up. It's going to store whether we are counting up or down. We want to generate the methods we need for this to work. Let's generate a getter, a setter, and a signal here. We do the same for up. We want to refactor this a little bit. We're going to move the definitions to the CPP file. Let's refactor and move to CPP. Everything, set up, move to CPP, up, move to CPP, and count, move to CPP. The other thing we want to do in the header file is to get rid of the public slots here, because we want to make these methods public methods. We don't want them to be slots. Control A, Control I to align and remove this. We want to take these fields here and move them down below in a private section of the class. Control A, Control I to align. Now we have our class, and it has a few properties. Count, which is an integer, and up, which is a bool. And this up boolean is going to store whether we are counting up or down. Now to make this thing a counter, we need to include QTimer. We need to create a field for timer. And we need to initialize these things in the CPP file. We are going to use initializer lists, and the order is going to be count up and timer. Count up and timer. Count is going to start at 0. Up is going to start being true. We want to count upwards by default. And timer is going to be initialized to a new timer. And the parent is going to be this thing here. We want to set the interval to the timer. Let's make it 500 milliseconds. And we want to connect to the timer and know whenever it times out. We're going to say connect timer, pound symbol, QTimer, timeout. We're going to use a lambda function. Let's capture everything and put in our body. Let's close this with a semicolon. And if we are counting up, we are going to increment the count. If it's not the case, we are going to decrement that. Okay, now we have our timer. The other thing we need to do is to provide methods that we can call on this thing to start and stop the timer. These are going to be public methods, so we can say helper methods. They are going to be QInvocables. And another QInvocable. They're not going to be complicated. They are very, very simple. Let's implement stop. And all they really are doing, start is starting the timer. And stop is stopping the timer. Just like this. Now we have the class. We need to expose it to Qt-Quick. We're going to go to main CPP here. We want to include our class. So let's say include counter and register our class for using Qt-Quick using this syntax here. We're going to say QML register type. We're going to pass in the type to be counter. We are going to say com_counter. This is the name identifier for your library. We're going to pass in a major version, a minor version, and the name that we are going to use in Qt-Quick to call this. And this is really how you register your type to be used in Qt-Quick and even be instantiated. Now that we have this, we can go back to Qt-Quick. Let's change the title here. We want to import our new library, the custom one. It's going to be com_counter The version is going to be 1.0, and you see that it is recognizable. Now we can say counter, and you see that it is recognized as a type. To show you that this is actually instantiated, we're going to go back to our counter CPP, and we are going to put in a debug statement to say that we constructed an instance of counter here. Let's include qdebug for that to work, and say qdebug here. Okay, let's build to see that we have no boo-boos. The build is fine. Let's run the application. Created a counter instance, but we see nothing in here. What we want to do is go back to main QML and put in a rectangle that is going to display the count that we have in the counter. The counter itself is not a visual type, but we can read its data and display that in a rectangle or in a text component. We're going to do that. Let's put in a column component. It is going to be centered in the parent, and we want a spacing of 10 by default here. We want to put in a rectangle component. Width is going to be 200, height is going to be 200, radius is going to be 20 by default. We want the color to depend on whether or not the count in the counter here is greater or less than 0. We're going to give it an ID, the counter here. We're going to call it mCounter. And we are going to use a ternary operator. We're going to say mCounter, count, greater or equal to 0. If that's the case, the color is going to be green. Let's move this column to the right. Otherwise, it's going to be red. This is what this says here. If this is true, the color is going to be green. If this is false, it's going to be red. Inside, we want to put a text component. ID is going to be mText. The text is going to be the count in the counter, and we're going to say mCounter count. It's going to be centered in the parent. We want a bigger font. Let's make it 20. And we want the color of the text to be white. Now we want to put in a few buttons. Let's import Qt Quick Controls. We go down below again, below the rectangle, and we put in the first button. The width is going to be 200. The text is going to be start. And when it's clicked, on clicked, we want to do mCounter start. We also want to put in a stop button. And it's going to say stop, and it's going to call the stop method on our counter here. Let's build. And if the build is successful, we're going to run this and see if it actually works. Okay, we have our rectangle here. We have a start button and a stop button. Let's click on the start button and see that we are counting and nothing is happening. Why is that? Why is that? Let's debug this. QML is not being updated because when we change the count, we are not emitting the signal that the count changed here. Okay, this is our problem. So we should come back here in the body of our Lambda function. And at the end, we're going to say emit count changed. And we're going to pass in the current value of the count. And this should do it. Let's run the application. Start. And you see that we are counting. I don't like the text here. It's very small. Let's go back to QML and make it a little bit bigger. For the rectangle, the text inside the rectangle, we can actually make it 40. Why not? This is better. Start 1, 2, 3 and stop. It stops. You start again. It keeps counting. Now I want you to notice that when we forgot to emit this signal, the count wasn't being updated. We were actually counting here, but the changes from C++ were not being propagated to Qt Quick. So you really should always emit the changed signal whenever the value changes in your C++ code. This is very, very important for property bindings to work correctly. Now that we can control the start and the stopping of our counter, we also want to be able to control whether it is counting up or down. We're going to go back to Qt Quick and put in 2 buttons. And we are going to paste this in. This is going to say up. And we are going to say mCounter up. We're going to set this to true. And we copy again, paste it in. We're going to say down. And up is going to be false in this case. When we count down, up is going to be false. And if we run the application, we should be able to control whether we are counting up or down. We have the buttons. So let's start again. 1, 2, 3. If we go down, you see we are going down. And when we cross 0, the rectangle becomes red because that's the behavior we programmed in here. And ladies and gentlemen, this is how you define your own type to be instantiable in Qt Quick. You see our counter item here is being controlled by the class that we defined in here. And we are being able to instantiate it because we exposed it like this by using QML register type. And if you want to know more about this method, you can select it like this. Hit F1, you're going to be taken in the help mode, and you are going to read more about it. It basically allows you to expose your C++ data in Qt Quick in a way that you can instantiate the method. You see the examples that they give you here. It basically is exactly what we did here. This is all for this lecture. I hope you enjoyed the capability of being able to expose your data in Qt Quick this way. In the next lecture, we're going to see how to define your own enums in C++ and expose the data to be visible and usable in Qt Quick. I'll see you in the next lecture. In this lecture, we're going to see how you can expose your C++ enums for use in QML. This is actually very easy, and it is not very different from what we've been doing so far. You create your enum like this. It's a normal enum. The only special thing you need to do is to decorate it with the QEnum macro like this and pass in your enum inside. And then in your C++ code, you need to register your enum as a type that you can use in QML. The syntax is really what we've seen before, but this time we want to register it as a type you cannot create in QML. And we say QML register uncreatable type. The rest is really the same. We pass in the name of the module. In this case, it is com-Blycon error level because we're going to model errors. You're going to see this in a minute. We pass in the measure and minor versions. We pass in the name we're going to use to refer to this class in QML. And then we pass in a string that is going to be displayed when a user tries to instantiate this type. This is a result of using QML register uncreatable type. When you try to create this type in QML, you're going to see this error here, and you should make it as descriptive as possible. In QML, you need to import your module, and you can access your enum values like this. We're going to go to Qt Creator and play with this. Here we are in Qt Creator. We're going to create our project. It's going to be a Qt Quick application. We're going to call it enum register uncreatable demo. Save it in the usual location. Hit next. Choose our Qt version. Choose our kit here and finish. We want to create our C++ class. The usual thing really. We call it arrow level. It's going to inherit QObject. We have our class here. Let's go to the header file. We are going to create our enum like this, enum put our semicolon here and put in the different values that we can have for this enum. We can have information, we can have warning, we can have debug and message. Let's clear this space here. The next thing we want to do is to expose this as an enum. We're going to say QEnum and say arrow value. The enum we define here. And this is all we have to do in this class here. The next thing we need to do is to go to the main CPP file and register this type. We're going to say QML register uncreatable type. And I just remembered that we need to include the class. We're going to say include arrow level. We're going to complete this. We're going to pass in com like coon. We're going to pass in the measure and minor version. We're going to pass in the name we're going to use in QML. And we are going to pass in a string to show when somebody tries to instantiate this type. This will do. We can now go to QML and see what we can cook up here. We're going to change the title here. We want to include our module. We're going to say import com like coon. And when this component is loaded, we're going to say console log. We can try to output any value in our enum like this. Let's run the application, and it should display the value of the enum here. Okay, here we have our application, and if you notice here, we have debug, and we are displaying 2 as the value of the enum. So if we go in the class, we can see that information is 0, warning is 1, debug is 2. Enums are just a way to wrap around integers and give them descriptive names that you can use in your application. And in this case, debug is representing 2, information is representing 0. Let's try this. You're going to say it. Let's run. We should see a 0 when the app runs, and this is what we have here. Okay, now you've seen how you can expose C++ enums and use them in QML. I want to show you a better way to do this if your class is really only exposing enums. Inheriting QObject and putting this QObject macro adds unneeded overhead to your application. If all you need is to expose your enum like this, you can take out this QObject macro, replace it with QGadget, and make the class not inherit QObject like this. We can copy this, comment it out, and do it like this. And we can take out the signals and slots as well, because they are not going to be supported if we don't have QObject here. Let's go to the CPP file and see that we can do something else. We also don't need QObject here because we are not inheriting QObject anymore. So we can actually copy this, comment it out, paste here, and take out the initialization of the parent and make it like this. We also need to update the constructor that we have in here to not use QObject like this. We're going to comment it out so that you have it, copy and comment out, and change it to not have a QObject parent like this. It's only going to have a constructor like this. Let's build the application and see that we have no boo-boos. Run and see that it works as it was working before. And this is what we had before. We are using another version of Arrow Level that uses the QGadget macro. And if you want to know more about this QGadget, you can select it, hit F1. You're going to be taken in the documentation where they talk about it. And they say that it is a lighter version of QObject for classes that do not need to inherit QObject but still want to use some of the reflection capabilities offered by the QMetaObject system. This is what it does. It is a lighter version of QObject macro here. Okay, this is all for this lecture. I hope you know how you can expose your powerful enums from C++ and make them usable in QML. In the next lecture, we're going to update one of the demos that we did before and make it use enums to control whether the counter is counting up or down. I'll see you in the next lecture. In this lecture, we're going to update the counter demo that we did in this chapter before and make it use enums to control whether the counter is going up or down. We're going to go to Qt Creator and do that. Okay, here we are in Qt Creator. We're first going to open that project. I am going to go where it is stored on my drive right now. The project is stored in here. I am going to open it in Qt Creator because I am going to copy files from it. But I just want to run it before so that you see it. The project looked like this when we finished it. You could start the counter, you could stop it, you could make it count upwards, or you can make it count downwards like this. If you look at the code that controlled this, if you go in counter, we are using a bool value to control whether this is going up or down. And we are setting that up in QML by setting the app value to true or false. We want to use enums to achieve the same thing. We're going to close this right now. Let's close all. Create a new project. It's a Qt Quick application as usual. We're going to call it counter demo enum version. We store it in the usual location. Choose our Qt version. Choose the desktop kit as usual and finish. We're going to copy some files over from the previous project because we don't want to redo all this. I'm going to click on the main CPP file of the project and show in Explorer. It is going to open where these are stored on my drive. I want to copy the counter class. I also want to copy the main CPP file and the main QML file. I'm going to copy those, close this, and close the project now because I don't need it anymore. I am going to go where my project, the new one, is stored. And I am going to paste in the files. It's going to say main QML and main CPP are already there. I'm going to override them, close this, and Qt Creator is saying that something has changed. It's asking me to reload everything. I want to reload everything. And you see the new QML file is available here. And if you go in main, you see that we are exposing our counter value as we did in the previous demo we did. We want to add the existing files we just added for counter class. We do that like this, select counter and add the files. They're going to be available right now. You see counter CPP is here, counter.h is here. We want to add another class that is going to store our enum. So add new C++ class. We call this counting because it's going to control whether we count upwards or downwards. We're going to inherit QObject. And we want to go to the header file. You can modify this to use QGadget because we're not really going to be using these signals and slots. But I am going to leave it like this. You can change it if you want, now that you know how you can do that if you need it. We're going to define our enum. The enum is going to be controlling whether we count upwards or downwards. And we need to decorate our enum with the QEnum macro as we did before. Just like this, we have our class ready, but we don't want people to be able to instantiate this class because it really is not meant to be instantiated. We are going to take the constructor here and make it private. This is going to prevent people to be able to instantiate this class. We're going to say private and make it private like this. Let's take out these spaces and our class is ready. Now we need to go to counter, include the class because it's going to be used in here. We want to comment out the line we had for app. We want to say QProperty and say counting, count direction. Let's call this counting. Let's take out this pane here so that we see the entire thing. We have our property, we have the getter, we have the setter, and we have the signal to notify if something changes. We need to generate all the methods that are needed for this property to work. We're going to right click on the QProperty macro there and select to generate the missing methods. We have our getter here, we have our setter here, and we must have our signal here, counting changed. We want to move the implementation of these methods in the CPP file. Let's refactor. Set counting is in CPP now. We want counting to move to CPP as well. And we want to take set counting and move it to the public section of the class. Let's take out this. This is what we want now. We can actually take this and move it along with the other methods. And this reminds me that we don't need these methods anymore, app and set up, because this property is commented out. We don't use it now. We can comment these methods. I don't want to remove them because you might need to look at them. I'm going to go to CPP and comment them out also. Set up is going to be commented out and app should be commented out. This is what we want. Let's check the class to see that everything is all right. This is almost all we need for this to work, but we need to go back to the CPP file and take out the initialization of the app value that we had here. We want to use mCounting, and we want this to be counting, count direction, and make it count down by default. Now let's bring up this pane again. Go into main CPP. We need to include counting. And we need to register the counting class as an uncreatable type. We can say QML register uncreatable type. It's going to be counting, and it is going to be in the same module as the counter, just to make things easier and to show you that you can do this actually. COM_BLY_COON counter. It's going to be 1 for the major version, 0 for the minor version. The name in QML is going to be counting, and we need to put a message that is going to be shown when somebody tries to instantiate this type in QML. We are going to say the same thing we always say: cannot instantiate counting from QML. It's not allowed. The last piece of the puzzle is go to QML. The counter module is already imported, so we don't need to change anything about that. But we need to go down to the up and down button and update how we set the C++ class to count up or down. We're going to say mCounter, counting, and we're going to say counting up. And you see that our enum is now available here to be used by us. Down below, we're going to make it count down. And this reminds me of something we might have forgotten to change on the C++ side. It is the control of going up or down in the constructor of our counter. You notice here that mmap is no longer available, so we need to say mcounting here and check to see if it is equal to counting upwards. So we're going to say counting count direction up. If it is going up, we increment the count. If it is going downwards, we decrement the count here. This is really all we need. Let's try and build this to see that it actually works. Looks like we have a warning here, warning of the initialization order of these things here. Let's go back in the header file and see the order we have. So it is mcount timer counting. We should move the timer in the middle. I like to have the same order because it makes things easier for the compiler, and I don't have these warnings. I hate to have warnings, and I try to get rid of them if I can. Let's rebuild. Let's run and see that we are actually able to control the direction of our count. It's going to go downwards by default because if you see here in the counter, we are initializing to go down by default. This is why we are going down. We can actually configure it to go up, and you see that it is going up minus 17, 16, 15. It's going to go up to 0, and then it's going to start 1, 2, 3, and things like that. You can bring it down again, bring it up. You can stop it, start it again. And it looks like we are doing fine in our refactoring to use enums to control the direction of the counter. We can actually come up in the CPP file and remove all these methods that we had uncommented before. We don't need them anymore. We go in the header file, take this out, and we should be all set. This is all for this lecture. I hope it shows you how you can practically use enums you defined in C++ to control the behavior of your application in QML like we are doing here. We should actually take this out too because we don't need it anymore. And one other thing we can try out before we close this lecture. Let me show you what happens when we try to instantiate something in QML that we exposed to be uncreatable. Let's try and create a counting object in QML. We can come here and say counting. It doesn't need to have anything inside. Let's build. We are going to build fine. The build is successful, but I want you to look at the application output. When we try to run the application, it's going to say cannot instantiate counting from QML, not allowed. This is the error that we specified in here. And this way, the QML engine is going to help you and stop you from making stupid mistakes by trying to build something that you are not allowed to build. This is all for this lecture. In the next one, we're going to see how you can work with object lists and object properties. I'll see you in the next lecture. In this lecture, we're going to show you how you can create object and list property types from C++. This may sound confusing at first, but there is a good chance you have seen QML code like this before. You have a QML component, and it has properties that take some other objects as properties. For example, in a list view, you can have a delegate to be another component that you define in here, something like this. This is an object property inside your QML component. And you may have seen also a way to pass a list as a property. Okay, for example, in states and transitions, you can define your states as a list like this and feed that to a property that is called states. We're going to build a C++ type that is called football team. We're going to model a football team, and we want our users in QML to have the ability to set their properties like this. They can have simple string property, title, and coach, but they can also have an object property in which they can pass a player, and they're going to have the ability to specify the players in an array like this. I know you might be thinking this is going to be a bit complex, and it really is, but I am going to try and explain it step by step, and you are going to understand by the end of the lecture. So how do we do this? We start by creating a class in C++ that is going to model our team, and you see that the class has a bunch of properties. We have the title, the coach. This is everything we had seen before. We have an object of player, and we have a pointer to player that we specify as a property here. And it also has a setter, a getter, and a notify signal. We have our list of properties that are exposed as a QML list property. This is actually a way to say that your class is using list properties to assign data to one of your properties that is called players. And if you look down here, we made it very clear that QML list property allows applications to expose list-like properties of object-derived classes to QML. Our classes that we are going to use here, and any class you really want to expose from C++ should derive from QObject. You already know this. You now know that you must create your class and give it a bunch of properties, and one of the properties is going to be the property that is going to take a list. Now, you also need a way to add the data that you specify in QML to the C++ class that you defined, and there are a few callback methods that you define that the QML engine is going to call to manipulate the data that you have in your C++ class. For example, we have a football team class, and when we put a player inside the football team QML element, we need that player to be added to C++, and the QML engine is going to use a bunch of methods that we specify in here in the players getter method. You see, we return a QML list property, and we pass in a bunch of pointers. The first pointer is a link to the object that is going to manage the lifetime of the list property. The second pointer points to the class or the object that holds this QML list property. In this case, it's going to be our football team. And again, we make it clear that the QML engine calls these methods when it needs to manipulate the data that we have in C++. And you see that the first method is going to be a method to append. The second method is going to get the count of the items. This is going to be the number of the players that we have in the team. The third method is a getter to get a player at a particular index. And the last method, you use it to clear the data in your C++ class. Your items are going to be instances of a player class that we're also going to define. And if we try to think in a more abstract way, player is an item of a football team. What we want is to give an easier way for a user to assign a bunch of players to the player's property. This is what we want. You also need to define these methods that the QML engine is going to use to manipulate your class. In the first slide here, we specify that these methods are going to be available. You can also pass null pointers here to specify that you don't have these methods, but it is always a good idea to put them here. So we define them in our class, and we're going to show you how you define this. You see append player takes a list of players, and it also has the player that you want to add. The player count methods has a list over which you're going to return the count. The player method gives you the list and the integer where you want to retrieve the player, and the clear players method takes a list that you're going to manipulate by deleting the other elements. And these are the implementation examples of these methods. Okay, I know all this may be confusing to many of you. This lecture was meant to make you familiar with what is required to build list property features into your C++ class. We're going to stop here, and in the next lecture, we're going to start and build this step by step. I'll see you in the next lecture. In this lecture, we're going to build a football team C++ class, and enable it to be used in Qt Quick with list properties. We're basically going to define our QML element like this, football team, and inside we're going to have a bunch of players, and we want to make it so that the QML engine is going to take the players that we have here in QML and build C++ objects on the C++ side, and this is going to work flawlessly. The goal in this lecture is to put together the plumbing necessary for all this to work. We're going to go to Qt Creator and do that. Here we are in Qt Creator. We're going to create our project. It's a Qt Quick application as usual. We're going to call it Object List and Properties Demo. Save it in a location on our drive. Choose our Qt version. Choose our kit here. Finish. The first thing we want to do is to create our football team class. It should inherit QObject as usual. We also want to create our player class. Let's do that. Player. It's going to inherit QObject as well. Player is going to have a bunch of properties. I'm going to just put them in here because I don't want to type all this. Let's fix the typo here. Control A, Control I to align, to have things aligned nicely. We want to generate all the methods that we need to get this working. I am going to refactor, generate methods, refactor on the second Q property here, generate, refactor on the third Q property here, generate. You see that a player can have a name, whether or not they are playing, which is represented by a bool value, and their position, which is also a string. We want to grab all these fields and make them available as private fields. We're going to go down here and make them private. And we want to move a bunch of these methods in the CPP file, their implementations. We're going to start with name here, move to CPP, playing, move to CPP, position, move to CPP, set name, move to CPP, set position, move to CPP, set playing, move to CPP. Let's go back to the header and see what we can do. This is not good enough yet. I'm going to capture all the slots, move them in the public section of the class, align things nicely. So that things are a little bit more readable, because things can get messy pretty quick here. Okay, our class looks better. This is our player class. Nothing fancy really. We just created the class, put in a bunch of properties. We want to go to the football team class, include our player class. We also want to put in a bunch of properties that I have prepared before to save on typing time. Control A, Control I. The first one is the title for the team, the name for the coach, which is a string. We also have a player who is going to be the captain of the team. We're going to generate the methods. We want to do the coach. Let's do that. And do the player here, refactor. And you see that we have fields generated for us. I want to cut out these fields, go down here, create a private section, put in these fields, Control A, Control I to align. I want to move these methods in the CPP file. You already know how to do that. Set title, we move to CPP. Set coach, we move to CPP. Set captain, we move to CPP. I think this is our last. We take these slots, move them to the public section of the class, take out the text here, and align this nicely so that it is presentable. We also want to do the same here. Okay, this is all. Our class looks nice and neat now. Now we want to enable it to have list properties. The first thing we want to do is to import QQML list property. Let's do that. And we want to create a Q property here. It's going to be QQML list property around player type. And it's going to say players. We want to hit enter because this is going to generate the names for the getter, the setter, and the notify signal. Okay, this also generated a setter that we don't need. So we're going to take out this set players. We don't need it because this QML list property here is going to wrap around a collection container that we're going to define in here. Let's actually do that. We're going to define a Q vector that is going to store pointers to player, and let's call it M players. We need to include Q vector for this to work. And if you don't know what a Q vector is, it is a matter of selecting it, hitting F1 here, go in the help mode. It is going to tell you it is a template class that provides a dynamic array. It allows you to store a bunch of objects inside, and you have a host of methods and operations you can do on that container. I'll leave you to read the documentation if you don't know what a vector is. Let's go back to our code, close this. We can click on this Q property and generate the missing Q property members. It's going to generate a players method for us, and it should have generated a players changed signal here. We actually don't need to pass in any parameter for now. So we're going to take that out and take out the spaces. And we want to refactor this method to be in CPP. Let's go down and look at this method. This method returns a QML list property that wraps around the player class. What this is really saying is that the class that is defining this, in this case, football team, is going to have a property that takes a bunch of players, and I am going to wrap around a bunch of methods that are going to be usable by the QML engine to manipulate the vector that stores the players internally in C++. I hope this makes sense. So what we're going to do is go down in here and return QQML list property. It is going to wrap around player because we want to have a list of players in QML. The first parameter is going to be an object that is going to manage the life of this list of objects. It is this football team here. The second pointer points to the wrapper data. In this case, it is the football team that holds the items. The third parameter is going to be the append method. We want to pass an address to it. So we're going to say football team append player. This is what we call it. We haven't defined it yet. The second method is going to give us the player count. So we're going to say football team player count. The third method is going to return a player at a given index. So we're going to say football team player. And the last method is going to allow us to clear the list or the vector of players that we have in this class of football team. So we're going to say football team clear players. And this is really all we need to return in here. We return a QML list property that wraps around players. And it's going to enable us to have list property capabilities in QML. And these methods are going to be used to manipulate the vector that we have in here. In other words, when you define your list like this, the QML engine is going to see that you have a list of players, and it's going to add these players one by one. How does it do that? It is going to call the append player method that we defined it here. But these are just like blueprints of the methods that we have to define. We have to actually define these methods in the C++ class, the header file, so that the QML engine knows what to do when it needs to append an item, clear the list, and things like that. We are going to define these methods in the private section here. Control A, Control I. The append player method is going to take a list and the player that we want to append to the list. The player count is going to take the list to return the player count for, and you get the idea. We just talked about this in the slides. What we need to do now is to implement these methods in the CPP file. Let's do that. Player count, player, and last but not least, clear players. And we need to pass in some names because we are going to do some manipulations in here. This is going to say list, and the player is going to say player. This is going to be a list as well. List. The other is going to be the index because we want to retrieve the player at a given index in this list. And here we are going to pass in the list that we want to clear. Okay, now we have our methods here, but these methods are going to need to operate on the vector that we have in here. But we may also need to manipulate this vector from other places in our code without needing to use these methods because these are specifically designed to be used by the QML engine. I am going to define a bunch of other public methods that are going to manipulate the list, and we are going to use them inside these QML engine specific methods, and this is going to give us a chance to use them when we need them later. I actually put those in the signals section. I should make them public like this and implement the method refactor add definition in CPP, refactor add definition in CPP, refactor add definition in CPP, and refactor and add definition in CPP. I should also give names to the parameters here. Let's say index. Again, these custom methods are going to manipulate this vector directly. So to append a player, we just say mplayers append player. To get the player count, all we need to do is to return mplayers count. Okay, the vector has a method that returns the count. We want to get a player at a given index. We can return mplayers at index. This is going to work fine. And if we want to clear the vector, we're going to say mplayers clear. We have a method here. Now we can return back to our methods specifically defined for use by the QML engine when it wants to manipulate the vector to add, clear, or get something from the vector. Before we do that, I want to come back to the documentation for QML list property. You can see this if you search for this in the documentation. The thing I want you to pay attention to now is the second pointer here that we passed. And we passed this pointer to be a pointer to the current class, which is the football team class. So we can cast this pointer here to a football team and manipulate the football team, which is what we're going to do in a minute. So what we can say is reinterpret cast. We want to cast to football team pointer. And what we want to cast is list data, which is what we passed as the second pointer here. And we can say now append player custom the method we just defined to add a player to the vector, and say player. I hope this makes sense. Player count is also going to work the same way, really. We're going to copy this thing and return. We forgot an R here. Player count custom, this is what we're going to return. This is going to return a player at a given index, so we can say return reinterpret cast player custom. This is going to take an integer. We are going to pass the index, and the player pointer that we get from this is going to be returned by this function here. We want to clear the list. No problem. We can reinterpret cast get a pointer to the football team and say clear players custom. I know there are a lot of moving parts for this to work, but the bulk of it is to have your property for list defined. So it is QML list property. It is going to wrap around the players, and we have a read method, which is players that we have here. We have a notify signal that is going to be emitted every time something changes about this list. Our players method returns a blueprint that wraps around the methods that the QML engine is going to use to manipulate our internal storage of players, which is stored in a vector right now. So we have an append method. The order is important. The first method is going to be an append method. The second method is going to be a method to get the count. The third method is going to be a method to get an item at a given index. The fourth method is going to be the method to clear the data in your storage container that you have in your class. And in our case, it happens to be a vector. Notice that you have to pass your player class, which is really an item class that you want to wrap around in QML. This is really all there is to having a list property feature built into your football team class here. Now we can go to main CPP and expose this class. We're going to include the classes that we need here. We're going to include player. We are also going to include football team, and we want to register these types. The registration is nothing new. Control A, Control I. We say QML register type. We say player. It's going to be in a module that we call com_football, measure and minor version, and the name that this thing is going to be available as in QML. We forgot to capitalize the B here. And for the football team, it is the same, com_football. It is going to be the same module, measure minor version, and it is going to be available as football team in QML. We can fall over to our QML file, import our modules. It's going to be com_football 1.0. Let's double check again. I think I have a typo in here. It is football, no capital in the middle. I'm going to copy it to play it safe, com_football, and it is going to recognize this. And notice that I can say football team right in here. It's going to have a title. Let's call this Rayon, a team from my country. The coach can be anyone. They have a captain that can be a player. Okay, you see that our thing is taking shape in here. The player can have a name. I think the player can have also a position. Let's say middle field. And the player can be playing or not playing. So we're going to say playing. The captain is going to be playing, so we set this to true because this is stored as a bool value, if I remember correctly. Yes, it is. Okay, let's try and build this and run it just to see that we have no boo-boos. We have a problem here, const. This is going to be a good learning opportunity. This cannot be exposed as const because we want to be modifying things wrapped inside here. So this method can't be const. Let's go back to CPP and also change it not to be const. Let's build again. And we seem to have a clean build. Let's run the application. And we have an empty window, which is what we expect because we have no other visual elements inside here. I want to assign items to the players property here. I'm going to put in my players in an array, and I am going to say player. Let's put the same properties just to save on typing time. Put a comma here. Put another player down here. Let's just put in 3 players. And what I'm going to do, the first one is going to be player 1. Let's name the captain. And the second one is going to be player 2. Third one is going to be player 3. And I want to come to the football team, add a QDebug class because we are going to debug output something, QDebug. And we want to know when the append player custom method is called. We're going to say QDebug add in player to vector. This is going to be enough. Let's run the application. We should see a call to this 3 times because we are adding 3 players in QML. And this is a proof that the plumbing that we did is working. Okay, adding player to vector, adding player to vector, adding player to vector. We can actually output the names of these players that we are adding. Let's do that. We're going to say player name. Let's run the application. It should say adding player 1, player 2, and player 3, which is what we defined in QML here. And this is really how you define your class and enable it to have properties that are lists. We can also do some minor manipulations to the football team we have in here. Let's give it an ID. Let's call it team 1. And when the component is loaded for this window, we're going to say component on completed console log and say we have and say team 1 players length because it's going to be stored as an array and say players let's say the team title, and it's going to say we have 3 players in the team Rayon Sport if this is working correctly, and this is exactly what we have here. Just to show you that you can use the data that you have in your football team to do some visual stuff, I am going to go down here, put in a list view that I have prepared to save some time on typing, Control A, Control I to align. You see that it really is nothing special. It is a list that is filling the entire window. The model is going to be team 1 players. We are getting all the players that we have in the football team. And the delegate is a rectangle that fills the width and a bunch of other obvious properties. Inside, we are just capturing the name field of the player and displaying that as an item in our list view. If this is working right, as we expect, we should have player 1, player 2, and player 3 displayed in our list view here. Let's run the application. Player 1, player 2, player 3. We are retrieving the list of players here and using it as a model for our list view here. This is cool, isn't it? We can actually add other players. If you don't believe me, we're going to add player name, let's say Daniel. Although I'm no player, I'm going to say none, and playing false. Let's run the application. Okay, you see that we have Daniel here. And ladies and gentlemen, this is how you enable your classes to be usable as list properties like this. The plumbing is really easy. I'm going to repeat one last time. You just have to provide your property as a QML list property, wrapping around your type that you define as you define any other type we've been using before. You have to provide a getter for the property here. In this case, it is player, and it returns a QML list property that wraps around the methods you're going to use to manipulate the storage container for your values in the class. And we define the methods to manipulate our vector here. This is really all there is to this. This is all for this lecture. In the next lecture, we're going to extend on this and make it work with inherited types. I'll see you in the next lecture. In this lecture, we're going to see how to work with inherited types from your C++ classes and how that reflects to QML. We're going to build on top of the previous lecture where we built a football team C++ type and made it available in QML and made sure it had the capability to take object properties and object list properties. In this lecture, we're going to make it capable of storing different kinds of players. For example, you see that in the players list here, we have a defender and we have a striker, and the captain can be a striker or a defender as well. We're going to build these kind of features in our class. Let's go to Qt Creator and do that. Okay, here we are in Qt Creator. We're going to create our project. It's a Qt Quick application. It's going to say inherited types demo, store it in a location on our drive, choose our Qt version, choose the kit we are using here, which is desktop, and finish. This is going to build on top of the previous lecture, so we're going to go there. Let's go where the main CPP file is located in that project. We're going to copy everything, the football team, main CPP and main QML, and the player files. We're going to copy all this, close the project because we don't need it anymore. We go in sources where the main CPP file for the current project is stored. We show in Explore, and we are going to paste in all these files. Control V. We want to override main CPP. We want to override main QML. Let's come back to Qt Creator, and we want to reload the entire thing. We have our file here. Now we want to add the existing files that we didn't have in this project. Football team and player are going to be added to this project. They are available here. Let's clean and build. Run qmake and build to see that we have no errors. Let's bring up the compile output, and luckily we're not going to have an error because it is exactly the same project we had in the last lecture. Okay, player 1 through 3 and Daniel as the last item of the player who doesn't play. Now we want to add our new classes. We're going to define a striker class and a defender class, and these classes are going to extend the player class. Let's do that. New class, striker. It's going to extend QObject. New class, defender. It's going to inherit QObject as well. We want to go to the player class and apply a few changes. The first thing we want to do is to provide a public void method, which is going to be purely virtual, making this class uninstantiable because it is going to be just like an interface. We're going to say virtual void play, just like this, and put equals 0. This is going to make this method a pure, which means you cannot create objects. If you try to do it, create objects from this class, you're going to get a compile error. But this says that classes that inherit this class have to implement this method. If they don't, they're also going to be virtual void, and it's going to simply be a chain of uninstantiable classes that you're going to have in your tree of parent and child classes. We're going to go to Defender. Let's start with Defender. It's going to inherit player, but we need to include player for this to work. Let's do that. Defender should override the play method, and they also have the capability to define their own methods in here. For example, they can say void defend, just like this. We should implement these methods in CPP. Let's include QDebug. And when you happen to call these methods, they are just going to say what the object is doing. So we're going to say QDebug name is playing here. And when we defend, we're going to say name is defending. And if it's not clear, this name method, we didn't define it here, but it is coming from the player class because we are extending it publicly. So we also have access to this method here, even if we didn't define it in the Defender class here. Let's go back to CPP and change a few things. We are no longer inheriting QObject. Here we are going to say player and pass in the parent that we have here. We want to carry out the same changes for the Striker class. First, it is going to extend player. We should include player in here. We should also override the play method and define our own method that says strike. Let's implement these methods. And we need to change the CPP file. This is going to be player because we are extending player. We should go back to the player as well and make the virtual method that we defined invocable so that we can call it from QML. We're going to say QInvocable. I actually can't confirm that we are going to call this, but I just do it so that I can call it when I need to. Let's clean the project again, because there are a lot of things that have changed. Let's run QMake again and rebuild the project and see that we have no errors. If we have errors, we're going to try and find solutions to them. Let's find something in here. What is wrong here? Let's go to main and see what we are doing here. Okay, we are exposing player as a type that we can instantiate. We shouldn't do this because it cannot be instantiated for the moment because it is a virtual class. So we should expose it as a type that we cannot instantiate. Let's do QML register uncreatable type and pass in a message when we try to instantiate it. This will do. But we need to expose the classes that we can actually use. So we're going to say Striker and Defender. And we are also going to expose these classes. So let's do that. We're going to copy the code so that we can adapt it in a minute. This is going to say Striker. It's going to be available in the football module. No problem. We're going to say Striker here. And this is going to say Defender. and it is going to be available in the same module, but we're going to call it Defender in QML. Let's clean the project, run QMake, and rebuild to see that we can build now. Looks like we have a clean build, but even if we can build, we still have types we cannot instantiate in QML. We have players here. Let's try and run it, and it should fail, saying that we cannot create a player in QML, which is not allowed. This is working the way we want. All we have to do is change the player here to striker, for example, and change the player here to defender, because we only want to work with children of players. We don't want to work with the player class directly. We're going to say striker here. Let's say defender. And the last player here is going to be a striker. Why not? Daniel is a striker. Let's try to build again. Let's run. And if everything is all right, we should see our list of players with nothing changed, because our defender and striker classes inherit the player class, and the interface is really the same. And this is how you can work with inherited types within your classes that you expose to QML to be used. You don't really have to do anything special. You just inherit the class like you do in standard C++. And this design is here only as an example. You can extend it however you like in your real applications. Okay, this is all for this lecture. I hope you know how to work with inherited types in your C++ code and expose the data to QML to be used by registering your types in your C++ code. In the next lecture, we're going to extend this and make it usable with default properties. I'll see you in the next lecture. In this lecture, we're going to see how you can enable default properties for your C++ classes that you expose to QML with list properties. The behavior we want is to be able to add players to our football team without explicitly specifying that we are assigning these players to the players property. Something like this. You define your team, you put in your coach, you put in your captain, and then you add a bunch of players. This is very similar to the list model API. We can actually go to Qt Creator and go in the documentation to see that. You see that you define a list model, you put in a bunch of properties, and you can put in a bunch of list elements inside. This is the same behavior we want to build for our football team type. We can go back to edit here and open the last project. We're not going to create a new project for this because it is very easy to do, but I wanted to expose it as a different lecture so that you have more time to focus on this. It is very important. It is going to make your APIs more usable, but the price to do this is very low. All you have to do for this to work is put in the QClassInfo macro, specify the first parameter to be default properties. It should actually say default property. I just checked on my notes and I had messed up. And you specify the property here that is going to be the default property for your type here. In this case, we want the players to be our default property, so we put it in here. You may not believe it, but this is really all you have to do for this to work. Just remember that the default property string has to be exactly like this. And in the second parameter, you pass in your property that you want to be the default property. This classify macro is used for more other things. You can go in the documentation and read more about it. But for now, we just use it to expose our default properties. Now that we have this, we can go to main QML. We can actually copy this team because we want to have two teams. I want to have the other syntax also available to you. So let's put in another team, call it team2. It's going to have another name, let's say APR. Let's keep the data the same. Really, it's not important. But the syntax we can use, we can take out the brackets here because we don't need them anymore, and take out the commas here because we can just add the players inside. The QML engine is going to recognize this as the default property, and it's going to work. It's not going to give us any error. Let's format this a little bit so that it is easier on the eye. Let's go down a little bit and clean this up. And this is really all. Okay, I want to change my output statement here to work on team 2, just to show you that it is working. And I want to change the names of the players here to be 4, 5, 6, and Daniel 2, so that we see that when we are adding these to their respective lists in the C++ classes. If you remember, in the last lecture in the football team CPP, we put in a debug statement to let us know when we add a player to the football team. But in this case, we have 2 football teams instantiated in QML. We have team 2, which is APR, and we have team 1, which is Rayon Sports here. Let's run to see that our code actually works. If it doesn't work, we're going to get errors, and we're going to fix them. You see that our thing is actually working. We are adding players to the first team, and we start adding players to the second team, 4, 5, 6, 2 for Daniel. And this is really working. We have 4 players in the team APR. This is what we are saying here. And if you look here, we really do have 4 players in the team 2, but we didn't assign a list to the players property like we did before. We are able to do this because we specified players here as our default property. I want you to know that this is just a syntactic sugar. It is just enabling you to write these things in this way because it is more readable. QML developers have been used to this way of programming, and it makes your code more readable by others. But internally, the QML engine is still storing this as a list and assigning the list to the player's property like this. This is really all we have to do to have default property enabled for our football team here. In the next lecture, we're going to show you how to work with grouped properties. I'll see you in the next lecture. In this lecture, we're going to see how to work with grouped properties. Here we have a few examples of QML components. These are the components we have actually worked with in a few previous lectures. We have a defender component, we have a striker component. In this lecture, we are adding another property which is called the player details, and we are exposing this as a grouped property. If you have worked with things like the font, the border, these are grouped properties. You can specify the font color, you can specify the font size. There are 3 main syntaxes you can use for grouped properties. The first one is the one you see here. You see details, you have your braces here, and inside you have your properties separated by semicolons. The second syntax is this one. It really is like the first one, but you are separating everything on different lines. And the third one is the most flexible one, but it is very easy to make your code messy by doing things like this. You basically say the name of the property, you put a dot, and you put a child property, and then you specify the value for that, just like this. We're going to see how to build this in your C++ code and expose this to be usable in QML, just like we see here. We're going to go to Qt Creator and do that. Here we are in Qt Creator. We're going to create our new project. It's going to be a Qt Quick application. It's going to be called Grouped Properties Demo. Save it in a location on your drive. Choose the Qt version you have installed. We choose our kit and finish. This is going to build on top of what we had before. So we are going to the last project we did for inherited types. We go where it is stored by clicking on the main file, showing Explorer. We are going to copy everything in here from Defender to Player. We're also going to add Striker. We copy everything, we close this, and we come back to our project. Let's close the QML file. We're going to go where the main CPP file is stored. The same thing we did before, really. We're going to paste in everything. Main CPP is going to be overridden. Main QML is going to be overridden. We're going to close this. When we come back to Qt Creator, we see that main has changed and main QML has changed. The next thing we want to do is to add the files that we just added to the project. We're going to select them one by one, player, player, striker, striker. This should be okay now. Let's clean the project. Run QMake and rebuild. Looks like we have a clean build here. Let's run to see that it works as it should, and we have our list of 4 players here. We want to add a class that is going to wrap around the properties that we want to expose as a group. We're going to call it player details because it's going to contain more information about the player. It's going to inherit Q object as usual. We want to give it a few properties, Control A, Control I to align. The first one is going to be the height, the weight, and the speed of the player. They are going to be real values, Q reals. We want to generate the methods for these properties. This is something you know by now. Let's generate for the last one. We're going to copy these things and make them available in the private section of the class. Control A, Control I to align. We want to move the methods to the CPP file. Let's refactor and move to CPP for everything. Refactor, move to CPP. Refactor, move to CPP. Refactor, move to CPP. Refactor, move to CPP again. We want to take these slots and make them available as public methods because this is the habit I have of doing things like this. You can leave them as public slots if you want. Let's clean this up a little bit. And you may not believe it, but this is really all you have to do to make your property available as a grouped property. You take your properties that you want to put inside and you put them in a class that you expose like this. All we have to do now is to go to the player class and include player details. And we want to provide the property of player details. We should do that like this property. It's going to be a player details pointer. It's going to be called details. We're going to hit enter because this is what we want, but we don't need a setter for this. We want to generate the methods for this. Refactor, generate. You're going to see the details method generated for you. We move it to CPP. Let's go to the header again. And we have our signal here. We don't want this method to be const. And we don't want this signal to have a parameter because we're not going to be using it. Let's go to the CPP file and remove the const keyword here. Let's go to the header file and see how we are storing the player details of ours. It is exposed as a pointer, but I don't want this to be a pointer. by default here. I just want this to be on the stack, but the details method, let's follow the symbol and a cursor to get to it, should return the address of this thing now, because it is not a pointer, it is some variable that we have on the stack. An object, not a variable. Okay, now that we have this in place, the remaining thing really is to go back to the main CPP file, include our player details class. Let's do that here. And we want to register the player details class as a type that we cannot create also. But we are going to use another syntax so that you also see that. We're going to say QML register type. We're going to say the type, and we are going to put an empty parameter list like this. What this does, it also registers your type as a type you cannot create in QML, but you don't get a custom message like this. QML is just going to fail over if you try to instantiate it. If you select this QML register type here and go to the documentation, you're going to be taken to this. This function registers the type in QML system. Instances of this type cannot be created from the QML system. It is just available as a type you can reference, but you cannot create objects of this class. In fact, if you go in QML and try to say player details, you see that it is not even recognized. Let's run QMake just to make sure and rebuild. Let's look at the compile output. This is taking longer. The build is successful. If we try to run this, we're going to get a message saying that player details is not a type. We are not allowed to instantiate something like this. This is what you get when you register your type like this without specifying anything inside. You get a generic error here that it is not a type you can use. I hope this makes sense. This is the main difference between QML register and create type and QML register type without any parameters in here. They are both uncreatable types. One gives you a nice message to look at. The other gives you this generic message you see here, but the effect is the same, and it is a matter of choice and preference on your part. Now you know that you cannot create this type, but it is available for use in your QML code. We can go to the player here. We're going to say details and put in our properties in here. I am going to put in a bunch of properties that I had prepared to save on some typing time. And you see that you get an error here. This is just Qt Creator giving you a false positive. If we try to run this, we're going to get our program run without a problem. You shouldn't be thrown off by this error here. We can use the other syntaxes for the other players. Let's pick this defender here and put in the data like this, Control A, Control I to align. It really is the same thing we did here. We're just moving everything to different lines. If we run again, I don't think we're going to have any problem, but Qt Creator is going to throw you off a little bit. We can also go down and use another syntax with dots, Control A, Control I to align. We say details height, details weight, and details speed, but this also is flagged as an error. But if we run the application, we're not going to have any problem. But this must be Qt Creator not recognizing what we have in here. It must be a bug, but I'm not sure. I'm going to close this and close all these applications here and close Qt Creator and open it again. Sometimes some of these errors go away. I can actually close Qt Creator, the entire piece of software. I'm going to save all first. Close the Qt Creator software. I have it opened again. I can open my recent project, which should be grouped properties here. Let's go to the QML file and see that some of the errors went away. And yes, here you see the details are recognized. Here the syntax is fine, no errors, but this is still flagged as an error. This must be a bug in the part of Qt Creator. highlighting these things as an error. If you have a way around this, do let me know. I might be interested. Let's run the application again. We see our data here. We are able to assign grouped properties to instances of our class in QML. And before we wrap up this lecture, I want to show you that you can actually read these properties if you want. We can come to the bottom when the component is loaded. Let's comment this out because we don't need it right now. We can try and print the height of the first player in the list of players from team 1. The way we do that, we can say console log team 1 players. We pick the first player, which is going to be at the index 0. We say details and height. If we check that, we're going to see that the first player is player 1. Their height is 333. Let's run. We should have a 333 printed here, and it is what we exactly have. This is all for this lecture. In the next one, we're going to see how to work with attached properties for your C++ types in QML. I'll see you there. In this lecture, we're going to see how to work with attached properties. If you have used QML for a while, you must be familiar with the syntax you see here when you want to know when a certain key has been pressed. And this is known as the keys attached property, which gives your item here the capabilities to know when a certain key on the keyboard was pressed. This is a capability it didn't have natively before, but the keys attached property allows us to have this capability. This is what attached properties are all about, adding features to your item that your item would otherwise never have. In this lecture, we are going to see how we can build such features for our own C++ classes. And what we want to do, we want to add timing features to our QML items, be it our own QML items like the person item here, or the other items that are already available in QML like rectangle here. So how do we do that? Well, there are a few things you need to do. The first thing you need to create is an attached class. The attached class is the class that is going to be the worker, the heavy lifter that provides the feature that you want to add to other classes. If you look in here, you see that it has an interval, it has a running property, and if you look down here, you see that it has a timer. You can see that it has all the fields that allow it to be a timer. And in the demo, we're going to see how exactly all these methods work to provide the timing capabilities for our classes. But what you need to know is that this class is the bulk of your features. It is going to be the class that provides the features that you're going to add to the other classes. But one catcher is that this class is never visible in QML. It is supposed to be in the background working for us, but the user in QML should never see this class. So what class does the user see? They see the attaching class. The attaching class is called to instantiate the attached class, which is the bulk of the features that we want to add to the other QML elements. It really has two requirements. It has to provide the QML attached properties method, and at the bottom, it has to provide this macro here, passing the name of the class in the first parameter and passing QML has attached properties in the second parameter here. You're going to see exactly how this works. Once you define this class, we can go in main and register our types. As we said, the attached class should never be visible in QML. That's why we register it to be uncreatable, as you see here. And we register the other classes that we're going to use in QML. Once you have this, you can create a person object, which is a custom item that we defined. You can give it timing capabilities, and it's going to notify you whenever a timer times out. You can also add the same capabilities to a rectangle, and it's going to work exactly the way we expect. Now that you have an idea about this feature, we're going to go to Qt Creator and build it step by step. So here we are in Qt Creator. We're going to create our project. It is going to be a Qt Quick application as usual. It is going to be called Attached Properties Demo. Choose the Qt version, choose the kit we want, and finish. The first thing we want to do is to create our classes that we're going to need. The first one is going to be the person class, which is a custom type we're going to add attached properties to. Let's do that. Person, it's going to inherit QObject. Person is going to have two properties really. Control A, Control I to align. It's going to have a name, which is a string, and an age, which is an integer. We're going to generate the needed methods for this to work. Here we are. We're going to move our fields in the private section of the class. And we want to move these methods to the CPP file. Let's do that. I really wish Qt Creator had a way to do this automatically for all the methods. But again, I am dreaming now. Let's do that for all the other methods. And we do set age right now. What else do we need to do? We need to move the slots in the public section of the class. Control A, Control I to align and remove public slots here. Okay, we have the person class. The next class we want to create is the attached class. Let's do that. It's going to be called timer attached. I love to put the attached suffix to the class that I intend to be an attached class so that I know it exactly when I look at the name. You can choose your own preference. If you don't put attached here, it is still going to work. The class is going to have two properties as well. Control A, Control I to align. We're going to generate the methods. You must be becoming an expert at this already. Let's move our things to the private section of the class. Move our methods to the CPP file. There are a few methods we still need to move. We move interval to the CPP file, and we move running to the CPP file. We want to tidy up our header file. Let's take these slots and move them in the public section of the class. And clean up the class a little bit so that it is presentable. This should be fine. We also want to add a timer because this is going to be counting for us, QTimer. And we need to define a timer object in the private section here, which will say QTimer, pointer timer. Let's go to the CPP file, initialize mtimer to new timer. The second field is interval. It's going to be 2 seconds, and it is going to start not running. Let's initialize this to false. We want to include QDebug in here and say that we are creating an instance of this class whenever this constructor is called. This is good for debugging purposes. We want to connect to the timeout signal of the timer. We're going to say connect. You already know how to do this. We've done this quite a lot in the course already. We're going to say mtimer, pound symbol QTimer timeout, and we're going to put in place a Lambda function that is going to respond to this. The Lambda function is going to put out a debug statement saying that we time out for an interval that we have specified. And the timer is going to emit a signal we want to capture in QML whenever we fall here, when it times out. So we're going to go back to the header file and provide another signal. Let's call it void timer out. This is exactly what we want. So we can come back to the CPP file and emit the signal whenever we fall in here. So we're going to say emit timer out. We're going to capture this signal in QML and do something when we get it. Let's correct this a little bit. Okay, and this takes care of our attached class. I want you to think about the usage of this class or its importance. It is a class that is used to provide timing capabilities to other QML components. And when other components instantiate this class, they are going to have access to these properties, interval and running. They are also going to have access to this timer out signal, and they can do something whenever the timer times out. They can also set their own interval or even specify if the timer is running or not running. So these are the features we can provide through attaching to this class. We are going to create our attaching class. It is going to be called timer. Let's do that. Timer. It is going to inherit QObject as usual. Let's go to the header. If you remember, this class has two requirements. One is to implement the QML attached properties method, which is going to return an instance to our attached class, which is timer attached. We should include this class of ours, timer attached. And we should implement this class here, refactor add definition in timer CPP. And all we need to do in here is return an instance of timer attached. So we're going to say return a new timer attached, and we pass in a parent, which is going to be the object here. You can return without passing in a parent, but it is recommended to pass in this object here as a parent, and this is going to be good for memory management for you. Let's go to the header and take care of the other requirement. The other requirement is to put QML declare type info here like this, but you see that this is not recognized. There is an error. What is wrong? For this to work, there's a class that you need to import, and it is QQML.h. Let's do that. Include QQML.h. And as you do that, you see that the error goes away. And this, ladies and gentlemen, takes care of designing attached properties for other types. I want to review what we did here. The person class has no connection whatsoever to timer and timer attached. It is just a custom type that we are going to add an attached property to. Okay, I want you to see that you can do this either on a custom class that you define like person here, or on other QML components like rectangle. What we want to do now is go to main and include our classes. We want to include timer attached, we want to include timer, and we want to include person. We also need to do our registrations. I'm going to do them in a batch to save on typing time here. The timer attached type is exposed to be uncreatable. Okay, you cannot create instances of this, but the timer and the person class can be instantiated anytime. Okay, before we go using the classes in QML, there is one thing we forgot. Let's go back to timer attached and look at when the user sets the running property to running. If the value passed in here is true, we should start the timer if it's not running. And if the value is false, we should stop the timer if it's running. We should implement that logic. After we set the running property, we should say if the timer is not running now, we should say mtimer stop to stop it, else we should start it. Now I think we're ready to go to QML and do our imports. Let's check main again to see what we should import. We should import timing 10 and people 10. Let's do that. Import (1.0), import 1.0. And if we go down here, we can put in a person object, person element. The name can be Johnson, and the age is going to be, let's do 33. And we can say something like timer running, set this to true, timer interval is going to be 3000 for 3 seconds, and timer on timer out, we're going to put in a block that is going to say console log timer out for person. Let's run. Okay, you see that it is timing out every 3 seconds. Is this every 3 seconds? And if you notice, the timer is going pretty fast, and it is going pretty fast because we forgot to pass in the interval in here. So let's say interval. We should also go to QML and change a few things. We want this to run every 2 seconds. Let's run the application. Okay, you see timer for person in 2 seconds, and this is working exactly the way we want. I want to show you that we can also do the same thing for another component. I'm going to copy this, create a rectangle, pretty quick rectangle. ID is going to be mrect. The width is going to be 200. The height is going to be 200 as well. The color is going to be yellow, green. And I want to put in my timer attached property. We should say timer out for rect. And let's make this a 5 just to make it different a little bit. We should see 2 messages for instantiating a timer attached property. And this is what we have here. And we have timers timing out for 2 seconds and 5 seconds simultaneously. And this is really how you build attached properties features to your own C++ types. You have to provide the attached type, which is really a class that has your features that you want to expose. And you have to provide an attaching class that has to fulfill 2 requirements, providing this static method, also adding this macro here. And for this macro to work, you have to include QQMLH. The rest is really going to main and registering your types. The timer attached property should never be visible to the user. That's why we register it as uncreatable. And the rest is really all you see here. We import the types and we use the attached property like we would for any attached property you have used in QML. This is all for this lecture. In the next one, we're going to see how to work with property value sources. I'll see you in the next lecture. In this lecture, we're going to talk about property value sources. If you have ever worked with animations in QML, you probably know this syntax you see here. Number animation on some kind of properties. And what this is going to do is going to animate this property in a range that you specify for a given period of time here. We want to see how we can build this kind of feature for our own C++ types. And the intent is to have them usable in QML. If you look here, we have a custom C++ type that is called random number. It is using property value sources to change the width here and to change the height here. And inside we have a property that is called max value. And this is going to be the maximum number, all the ceiling of the numbers that we're going to generate with this random number C++ type. So how do we build this? Well, you start by building a custom C++ class. The class has to inherit a specific class called QML property value source. Inside the class, you have to provide this macro, and inside put the name of the QML property value source class. And you have to override the set target method and provide a slot that is going to update the property. And of course, you have to have a field for the property that you want to manipulate in here. These are the basic requirements for this to be recognizable as a property value source, but you also have to build in your own logic that you want to follow to update the properties. In this case, we are building a random number generator. So we are going to use a timer here that is going to generate a number at a given time interval. We're going to see how this works in a demo we're about to do. But the important thing is to put together the building blocks that make your class recognizable as a QML property value source. Now that you have a basic idea about this, we're going to go to Qt Creator and see this in action. Here we are in Qt Creator. We're going to create a new project. It's going to be a Qt Quick application as usual. We're going to call it Property Value Sources Demo. Save it in the usual location. We're going to choose our Qt version. Choose the kit we want to use, desktop in this case, and finish. Let's change the title here to say Property Value Sources Demo. We want to create the class in C++, so we say new CPP class. We call it random number. It's going to inherit QObject as usual, and we finish. We want to include a few classes. One is going to be QQML property value source. The other is going to be QQML property, and we want to include QQML.h because it's going to contain the macro for the interface we're going to use in a minute. We want to do a multiple inheritance here and inherit QQML property value source as we saw in the slide. Let's do that. We want to put in our macro. And if you want to know about this macro, you can copy it. Go in the documentation, put it in place here, double click on here, and you're going to see this macro tells Qt which interfaces the class implements. Okay, we are saying that we implement the interface for this class here. Next, we want to put in the set target method. We're going to say virtual void set target. It's going to take a const reference to QQML property. We also want to provide a private slot that says update property. This is going to update the property whenever we need to update it. Let's put an S here. In the private section of the class, we want to have a field for QQML property. Let's call it mTarget property. We also want this class to have an upper bound max number. Let's put a property to model that because we want that to be manipulable or configurable from QML. We're going to say QProperty. It's going to be an integer. This will do. We want to generate the methods, and we move them in the CPP file. Let's go up again, find the other one, set max value. Let's move to the CPP file. The last thing we want to do is to implement set target and the slot that we defined here. We're just going to put in the implementation blueprint. We're not going to implement just yet. Refactor, put in CPP. We want to clean this up a little bit. I'm going to move the slot in the public section of the class because it is going to be used here. Control A, Control I to align. We want to include QTimer because this is going to be updating values at given intervals of time. Let's do QTimer here. Create a QTimer object in our class. And go in the CPP file, do some initialization. We want to initialize the max value to 100 and the timer to new QTimer and put in a parent. This will do. Down here, we want to connect to the timeout signal of the timer and connect it to the update property slot here. Let's do that. We're going to say connect mTimer signal timeout this slot update property. This will do, and we want to start the timer. We're going to say mTimer start. Now we want to see what we do when we update the property. Before we do that, I want to visit the QQML property class to see some kind of things we can do on the class object. Let's go in the documentation and find it. It is a class that abstracts accessing properties on objects created from QML. If you look at it, it has a few methods that we might be interested in. We have a write method that we use to write to the property, and we have a read method that we can use to read from the property. You can read more about this if you are interested. We want to write our property right now. Let's go in the CPP file again, find the method. We're going to say mTarget property, write, and we want to write a random number that we generate. Qt happens to have a class to help us in generating a random number. So we're going to say include QRandomNumber generator. It is this one. You can visit the documentation of it if you want to know more about it. What we are going to use is this public static member global to generate a random number, which is going to be an integer. How are we going to do that? We're going to close this, come back to the CPP file and say QRandomNumberGenerator global and say bounded, because we want a bounded number, and pass in mmax value. This is going to give us a random number in the range from 0 to the max value that was specified in here. We initialize this to 100, so we're going to have between 0 and 100. We can put the last semicolon here. And the last thing we need to do for this to work is to set the target. This is going to be a piece of cake, target property equals prop that we pass in here. This should be all we need for this to work as a property value source. We're going to go to main CPP, include our class, random number. We are going to register the type. We're going to say QML register type. It's going to be random number. The module is going to be random util because that's what it is. The version is going to be 1. Minor is going to be 0. And it is going to be available in QML as random number. This should be all we need now. Let's head over to QML, import our random util module, put in one rectangle, ID mrect. Let's give it a width of 300, a height of 300, a color of Dodger blue, and do something crazy by saying random number on radius, and we have to specify the max here. And you see that max value is recognized from Qt Creator. We want to have a max value for the radius of 100. Why not? Before we run the application, I want you to guess what is going to happen. We are going to see a rectangle. It's going to have this width and this height. It's going to be this color, and its radius is going to be changing every 500 milliseconds. Why is that? Because this random number generator is generating our number every 500 milliseconds, and I noticed that I didn't put in my time. Sorry for that, but it is going to be triggered every half second. And when this is triggered, this update property method is going to be called. We are going to generate our number here, and we are going to write that number to the property, and the result is going to be that that number is going to be written to the radius here, and we are going to see the rectangle changing its rounded corners as the radius changes here. Let's run, and hopefully it's going to work. You see that our thing is really working here. We are changing the rounded corners because the radius is changing every half second. And this is really how property value sources work. You just have a few rules you have to follow. You have to inherit this class here. You have to put in your interface macro here. You have to provide the set target method that is going to be used to set your property as a target. We also have to update the property every time we change it in our class, In this case, we are doing that when the timer times out here. We can configure this, let's say 1/2 second. Let's wait until the app runs, and it's going to be changing every 1.5 seconds. We can go crazy and change the radius to be something really big, the max value. Let's make it 300, and it's probably going to become a circle as we do that. Okay. This is really big, isn't it? Let's try something else. We can also do a random number on width. Let's do that. Let's take this out, random number on width, and let's say max value. It's going to be 700. Why not? Let's run, and we should see some crazy things happening right now. Okay, you see that as the width changes, our rectangle here is also changing the shape. I know this is a silly example, but it displays the capabilities you can build into your class if you happen to need to expose your class as a property value source. This is all for this lecture. In the next one, we're going to zoom out a little bit and compare different registration types that we have seen so far. I'll see you in the next lecture. In this lecture, we're going to try and sift through the different ways we showed to register your C++ type for use in Qt-Quack. These are the different ways we saw so far. You can say QML register type and pass in all the information. QML register uncreatable types allows you to register types you cannot instantiate in QML, but QML register type without parameters inside also registers a type you cannot instantiate in QML. We're going to try and talk about the differences between these two. The first type we saw is this one, and it is probably the easiest one to understand. You use it to register a type that you intend to instantiate in QML. For example, here we are registering a person type, and we want to create person types in QML like this. This is easy to understand. The second one we saw is to register an uncreatable type. The obvious thing about this type is that if you try to create an instance of it in QML, it is going to fail and show you an error message that you specified in the last parameter here. So this is cool if you need this kind of things. This is usually used for enums and attached properties in QML. Now comes the confusing one. This also is used to register types you don't intend to instantiate in QML. The documentation says that instances of this type cannot be created from the QML system. This function should be used when the type will not be referenced by name. You don't intend to access the name of this type in QML. Specifically, it has to be used for C++ types that are used as left-hand side of a property binding. And there is a better example for this in the documentation. That's why I left this hint here. So we're going to go there and look at it. So here we are in Qt Creator. We are going to go to the Help tab and type in QML register type and see what we get. It is going to take us here to the method we want immediately. This is what we saw. You see they have an example here. We have a class called bar, which comes and ends down here. Inside we have a QString that is called mbaz. We have a fill class that contains an object of bar. In QML, we can assign to baz like this. You see they say bar, baz, and they assign something like this. You don't need to access the name of bar really. All you need to know is that this type exists, and you register it like this by not passing in any parameter because it doesn't need a name to be accessed in QML. It is accessed through another class. I hope this makes sense. And this is one case where you might need to use this. But in many projects that I have seen this type of registering and register uncreatable type used interchangeably, and you have to choose whatever you feel works better for you. This is all for our review of QML register type and its different overrides that you can use to register your C++ types for use in Qt-Quack. In the next lecture, we're going to wrap up the chapter and review some of the most interesting things we had a chance to look at in the chapter. I'll see you in the next lecture. You're finally done with this chapter. This was really a long one, and congratulations on getting here. To keep things in line, let's go through what we saw in this chapter. We started by showing you how you can register your types. This chapter revolved around registering your C++ types for use in QML, and we saw different ways to do that. We have also seen ways you can expose your enums in C++ for use in QML. Next, we looked at how you can enable your classes to take advantage of objects and list properties. And we were able to model a football team class that we can use in QML by putting in the players like this. This can quickly boost the usability of your QML types. We saw how to work with inherited types, and we created the striker and defender classes and made the player class a parent class that is abstracted away. You saw how easy it is to work with default properties in your classes. You learned how you can expose your data as grouped properties. Next, we saw how you can work with attached properties in your C++ types. There are 3 things that are involved for this to work. You need to provide the attached class, you need to provide the attaching class, and you need to find a client that is going to use your attached property. In the examples we did, we used person and rectangle as our clients. And last but not least, we looked at property value sources. There are a few requirements on the part of your C++ class to work as a property value source, but we looked at the demo and you had a chance to see exactly how this works in practice. I hate to say it, but this is the last lecture in the course. And I would like to take this chance to congratulate you again on making it here. In the next chapter, we're going to try and review a little bit everything we saw in the course and give you a few tips on how you can go even further if you want to keep learning more on this fascinating topic of interfacing your C++ code to QML. I'll see you in the next chapter. You're finally done with the course, and I hope you really learned a few tricks you can use to interface your QML to C++. The course really revolved around 3 ways you can expose your data from C++ to QtQuick. In the start of the course, we looked at how you can use context properties and context object to expose a ready-made C++ object and be able to use the data contained inside in QML. We were able to call methods on the object, and these methods were manipulating the fields that we have in the class. The other way we saw was to use different overrides of QML register type, and we saw that you can use it to either register a type that you can instantiate in QML or register a type that you cannot create in QML using QML register uncreatable type or using QML register type without parameters inside. These are the basic chief weapons we have to interface between QML and C++. On top of these, we also saw some different constructs you can build for your C++ types. We saw how you can build in features like list properties, attached properties, property value sources, and a few other cool features that are very good to have in your QML API. So now that you have these cool tricks under your belt, what next? I would really recommend to practice this as much as you can, and nothing is going to beat this. If you have a project you are working on, try to use the tips you got from the course and try to expand on what you learned here and even learn much more by yourself. So this course tried to give you the basics of how you can interface your QtQuick to QML. Right now, we're going to go through the documentation and show you a few other things you can look at. Here we are in the Qt documentation. We are going to look at an overview of how you integrate between QML and C++. They talk about a few of the things we talked about in the course. You see, they say that QML is designed to be easily extensible through C++ code. This is really what we did in the course. Here they talk about the benefits of being able to integrate between C++ and QML. You can separate the user interface code from the application logic. This is really what we did. You have the capability to invoke C++ methods from QML. We did that a lot. They also say that you can create your own QML types. We also saw how to do that in the course. What I really want to show you is this graph here. And it really helps in choosing the correct way to integrate between your QML and C++. They give you a few steps you could follow to know which kind of integration you're going to use. If you look in here, you see that they have QML register type. They have QML register singleton type. We didn't look at this, so for now you can ignore this. They have QML register uncreatable type. They also have set context property. And you can look at this to kind of have another perspective on how to understand these things. Again, I know I didn't talk about singletons. This is another topic. I couldn't cover it in the course. I plan to cover this in another upcoming course. So if you are interested, stay tuned and I am going to notify you when the course becomes available. And down here, they talk about exposing attributes of C++ class to QML. This is really using the QProperty mechanism and be able to propagate the changes between QML and C++. Down here, you see that they talk about context properties and they talk about other concepts that you really should read about. So I'll leave you to read this entire thing. It is a good thing to read after you finish the course. It is going to help you have a big picture about what we learned about in the course, and it is going to give you a few pointers on how you could improve on the knowledge that you already have today. Okay, I also have a few things I would recommend you read about if you want to dig deeper in this topic of interfacing C++ to QML. Using custom C++ models is a very interesting topic because it is going to allow you to take advantage of the model view architecture that is already available and mature on the C++ side of Qt, and you can take full advantage of it without really doing too much work. So it is something good to look at. You can also learn about how to expose your classes as singletons, building your own visual types, versioning your QML types so that your users can run different versions of the APIs that you provide. These are the topics I do recommend to look at if you really want to know more about how you can get your C++ and QML sides to talk to each other. I have to say, I am working on another course that is going to talk about these topics. So it is very probable that by the time you watch this, the course is going to be available. So it might be a good idea to try and check it out. Why not? And in fact, if you are our student, you are entitled to take any of our published courses that are available and listed in the next lecture. So it is a good idea to check it out and see if there is something you might like. The list is shown here and you see that we have some Qt development courses, we have some courses on XMPP, and you can look at all the other courses on Qt and see if there is any topic that interests you. And if you are interested, all you have to do is click on the link here and take the course. The discount is going to be already applied. Okay, this brings us to the end of the course. I would like to thank you for enrolling. If you got some value out of the course, I would appreciate it if you took some time to leave your review. But most importantly, I am wishing you well on your journey to become a better Qt developer. Till next time, bye.